Hello, happy people. Let's try this. This is take 3 today on the chapter 15 with the IV solutions. And the first thing on the handout, it talks about the IV solutions and what they are. We have dextrose. And dextrose has the abbreviation with a D. And we have water, has abbreviation W. Dextrose is also our glucose. That's what dextrose is. It's the same thing as glucose. We have saline, which has an abbreviation S. And we have normal saline. Don't know what the difference is. And it's NS. And then we have sodium chloride, which is NaCl, which is the chemical abbreviations for sodium and chloride. And then we have Ringer's lactate, and lactated Ringers. And they're basically the same thing, probably two different companies that make them. It's just a mixture. The Ringer's lactate, the lactated Ringers, is a mixture of sodium chloride, sodium lactate, potassium, and calcium chloride in water. But they're both the same thing. Okay, the first example 1, you have a bag of IV solution, and it has the numbers D5W on it, or the letters D5W, and it says it's a 5% dextrose injection. Well, D5W is a 5% dextrose. In water, or 5% dextrose injection, but it's in water. So the 5 here represents the 5%, and the 5% is the same thing as saying 5 grams per 100 milliliters. So we get 5 grams of dextrose per 100 milliliters of water, or a solution. So the 5%, I could say it as 5 over 100, because that's how you write a percent. And then that's where I get my 5 grams of 100 milliliters. Example 2, you're given another bag of lactated Ringers, and it's a 5% dextrose injection, but it's lactated Ringers, and it's written as D5LR. So 5% dextrose in lactated Ringers. So this one's 500 milliliters. So we have two different types of bags. The first one was a 1,000 milliliter bag, but it's still 5 grams per 100 milliliter. And our 5% dextrose and lactated Ringers, even though it's a 500 milliliter bag, it's still 5%, so it's still going to be 5 grams per 100 milliliters of lactated Ringers. I've got two different number 2s going. Okay. I think I was looking at a different worksheet. But the other number 2, the one that I think is on your worksheet, it's D10W, and it's 250 milliliters IV every 6 hours. That's your orders. So how much of the amount, get my tongue untied this morning, amount of dextrose in the 250 milliliters of solution. Okay, well, since it's 10, that's 10% So that would be 10 grams over 100 milliliters. And I can reduce that. My zeros cancel. So I have 1 gram and 10 milliliters. And then I'm going to multiply that times the 250 milliliters over 1, because 1 gram over 10 milliliters times the 250 milliliters. So I'm basically taking the 250 milliliters. Oh, my milliliters canceled. It's going to be grams, sorry. Milliliters canceled. And then 250 grams over 10. Those zeros canceled, which gives me 25 grams in 250 milliliters. Okay, so that's for the first couple. The next thing we look at in chapter 3, or chapter 15, is the IV flow rates. And we have some of them which are on an infusion pump, and that's what we're going to look at first. And then we have some that are gravity flow, or that are they're manually operated. But we're going to look at the infusion pump first. The infusion pump is always in milliliters per hour. Okay, so anytime you're finding the rate, you want to get it down to so many milliliters in 1 hour. So example 3, I have an order for D5W, 250 milliliters, IV over the next 2 hours by infusion pump. So I want to know the flow rate. Okay, so what is my flow rate? And it'll say something like the flow rate, calculate the flow rate. But the flow rate is your total volume of the IV bag divided by your total time in hours. Now some of these we're going to have to convert to hours, some of these are already in hours. So all I need from my order for this one is the 250 milliliters in the 2 hours. Okay, so to get my flow rate, I take 250 milliliters over 2 hours. I want to reduce it, even if it becomes decimal, I still want to reduce it to where I have milliliters per 1 hour. So I want just 1 hour. So I know 2 goes into 250 125 times. So it's 125 milliliters per 1 hour, which we would write as 125 milliliters / hour. Okay. Can't write so far close to the edge. The next example, 4, again, we're going to calculate the flow rate. I have an order for 50 milliliters, D5, 1/2, normal saline. I thought that was sodium chloride. Looked at it wrong. Normal saline in 30 minutes. Infusion pump. And then my infusion pump again is going to be milliliters per hour. So to find my flow rate, all I'm going to need is the amount of IV solution and the time. So it's total volume of IV bag over time in hours. You can say total time in hours or just time in hours. So my total volume in this case is the 50 milliliters. And my total time in this case is the 30 minutes. Alright, so I've got a time or volume over time, but I need my time to be in hours. So I have to convert it. Minutes is on bottom, so minutes has to be on top, and hours has to be on bottom. And there's 60 minutes in 1 hour. So that's going to cancel. I'm going to do a little conversion. 30 goes into 30 one time, 30 goes into 62 times. So the only thing I have on the bottom is hour. So I have 50 times 2, which gives me 100 milliliters per hour. Number 5 is the same way. The order is for 2.5 liters. IV, I don't know, I didn't write it down what it was, over 20 hours. And it's in an infusion pump. I'm going by my notes, so I didn't write it all out. So I know that I have 2.5 liters, that's my total volume, over 20 hours. But remember, my infusion pump is milliliters per hour. So it's already in hours, but it's in liters. So I'm going to have to convert my liter to milliliters. So I know in 1 liter there's 1,000 milliliters, so 1,000 milliliters over 1 liter. My liters cancel. I can take this 0 and cancel that 0. So now I'm doing 2.5 times 100, and I get 250. 2 times 1 is 2. 250 divided by 2 is 125. And then I've got milliliters over hour, so milliliters per hour. Okay, so that's the first part. I'm going to end it here, and then I'll pick it up with the manually regulated IVs.